Let's talk about types of polynomials. The number of terms an expression has determines the name that we give it. Terms are separated with either addition or subtraction. Here is our first polynomial. This one is a special polynomial, 5x squared, because it's just one term. Since there isn't any addition or subtraction, it's just one term. We call an expression with one term a monomial because the prefix mono means one or single. For this monomial, 5 is a coefficient. It is multiplied times the x squared that is behind it. X is a variable. It can change values. And 2 is an exponent. So when there's one term, we call it a monomial. If we've got two terms, then we're going to call it a binomial. Remember when you were a little fellow or fellowette, as the case may be, you had something with two tires on it that you rode around the neighborhood on. You called it a bicycle because bi means two. Binomials have two terms. 5x squared minus 3x is a binomial because the minus sign separates us into the first term, 5x squared, and the second term, minus 3x. Now, notice that I've included the minus sign with that second term. The sign is part of the coefficient. So the coefficient of the second term is minus 3 for this binomial. The leading coefficient is 5. The one that is on the front of our polynomial is the one that we call the leading coefficient if we've written the terms in descending order of power. The leading coefficient here was 5. Well, before you had the bicycle, you had something with three tires on it, a tricycle, because tri means 3. So a trinomial has three terms, like 5x squared minus 3x plus 2. The minus sign separates the first two terms, and the plus sign separates the back two terms. Now, 2 can be called the coefficient of the third term, but usually it is just called a constant value. No matter what you substitute in for these x's, the back part is constantly going to be 2. It's not going to be changing value. So we usually call the term that doesn't have a variable tied to it a constant value. If we have 4 or more terms, we usually just say polynomial. So one term is a monomial, 2 terms binomial, 3 terms trinomial, anything else is a polynomial. Now, we mentioned that we want to write things in descending order of power, going from the largest exponent to the smallest exponent. We want to do this because it helps us to determine the degree of the polynomial. If you've got something that's just in one variable, the degree of the entire polynomial is going to be the highest exponent that you see. For instance, with this polynomial that has 4 terms, the first term has a degree of 3 because its exponent is a 3. The second term has a degree of 2 because its exponent is a 2. We have an understood exponent of 1 attached to this x, so the third term has a degree of 1. Constant values always have 0 for their degree. So if we look at each of these terms, which one had the highest degree? The first term did, a degree of 3. So the degree for the entire polynomial is 3. The coefficient of the first term was 8. It had the highest exponent, so we would say that 8 is the leading coefficient for this polynomial. Remember, negative 3 is the coefficient of the third term. Signs are part of coefficients, and also keep in mind that constant values have 0 degree. If something is in one variable, then the highest exponent that we see is the degree of the entire polynomial. But if we have more than one variable, to determine the degree, we have to take the highest sum of exponents within a single term. For instance, with the trinomial that is here, The first term, we've got 2 and 3 for exponents there. The sum of these, adding them together, would be 5. So the degree for the first term is 5. Here in our second term, we have an understood 1 and 2 attached to the y. So 1 and 2 together add to make a degree of 3. Remember again, constant values have 0 degree. So what was the highest sum of exponents within a single term? We had 5 on the front, 3 in the middle, 0 on the back. Looks like 5 is the highest sum, so the degree for this trinomial would be 5. The highest sum of exponents, if we have more than one variable, is the degree of the entire polynomial. Our leading coefficient is 5, since it's attached to the term that we got our degree from. The coefficient of the second term is -3. And again, keep in mind, constant values have 0 for their degree.